Okay, now we're in part 4 of our exponents lesson plan, and we're going to learn how to do equations with the exponents now. We covered lesson 1, we covered multiplying. Lesson 2, we covered dividing the exponents with the same base. Lesson 3, we did multiplication, power on power. Now we're going to solve equations with it, and also we're going to learn how to solve even with a different base. Okay, so usually we have the same base and we cannot apply these rules unless the bases are the same. Okay, so let's start with number 1. Not a very hard example, and we're going to start off something not too difficult. So we have 9 to the 2x power equals to 3 to the 8x plus 2 power. Now as you see, the bases are different. So your goal is to try to make the bases the same. So you're thinking, how can we make these two bases the same? One's 9, one's 3. But you gotta think that 9 is a power of 3. That's where 9 comes from, right? So you gotta know, it's very important when you're doing exponents in these chapters to know your most general powers, which is your 2's, your 3's, and your 5's mostly. That's as much as you need to know. You don't really get that many 6 kind of problems. You might get a 10 kind of problem, but 10s are easy to do because 10 squared, 100, but those are easy. 2, 3, and 5 probably the most general powers you need to know, like 2, 4, 8, 16, 32, 64. You need to know those powers. It's always the same numbers over and over again. So over here, 9 is a power of 3. So it's what? 3 squared, right? So you can write 9 as 3 squared and then write 2x power, right? Because this is the same thing as 9, 3 squared, right? Now is equal to 3 times 8x plus 2. Okay? So now what we do here, we have 3 squared 2x. Remember this rule? Power on power. What do? You multiply the x, right? So you get 3 to the 4x equals to 3 to the 8x plus 2. You see how that happened? It's the same rule. When you get power, you multiply the exponent. So 2 times 2x is 3 to the 4x, okay? So 3 to 4x equals 3 to the 8x plus 2. Since the base is the same now, you can just set the exponents to be the same, right? So now you can write 4x equals to 8x plus 2, okay? And we can now solve for x. What do? You subtract x, 8x on each side, right? So you will get, let me write it up here so we have a little more room. Okay, so you subtract 8x on both sides, and you get negative 4x equals to 2. Okay, and what do you do now? Negative 4x equals 2. Since it's negative 4 times x, you divide by negative 4, right? And you will get x equals to negative 2/4 or negative 1/2. Okay, and that's how you do solving for exponents. And then you'll see number 2, you're going to get a much more challenging kind of problem. So you got a lot of things going on. You can see here, all the bases are different right now. It's crazy. You got 8, 4, 2, 16, all different bases. You got multiplication going on of exponents. You got division going on of exponents. You got the power on power. So you got a lot of things going on. You're solving an equation right now. So you get the whole enchilada, the whole caboodle in this one problem. And you're going to learn a lot just from this one problem. So what do you do first here? Well, how about this? Let's make the bases all the same, because if you make the bases the same, it's much easier to do the problems, right? So what's 8 in general? It's 2 cubed, isn't it? That's why it's important to understand, to recognize the most general numbers, which is like 2, 4, 8, 16, 32, 64, all the powers of 2. Because once you see them, it's the same numbers over and over again in textbooks. And math teachers will give you the same numbers over and over again. You just have to recognize it, that's all. So 8 is really 2 cubed, right? Okay. 4 is what? 2 squared, right? And 2 is just 2 to the x. Okay. All to the 2 power. And while we're at it, might as well just change the 16 to the 2 since all the bases are the same, okay? What's 16? Is 2 to the 4th power, right? And then we copy the 4th power right here, okay? So now you can see it's a little cleaner now, okay? So what do we do up here, okay? We 2 cubed to the 2x power. We use the power on power theorem, right? You just multiply them together. So 2 cubed times 2x is just 2 to the 6x. I already write it over here so we have a little more room. Okay? 2 squared to the 4x, so you just multiply exponents. 2 times 4x is 8x. Okay? And then all over 2x. 2 to the 2x equals to, what's 2 to the 4th to the 4? Well, it's 4 times 4, which is power and power. So it's 2 to the 16 power. Okay? You see how that is? Okay? So now, let's go with the first theorem again. 2 to the 6x times 2 to the 8x. You add the exponents with the same base, right? It's the same base now. Before it wasn't. That's why you can't do it before. Before you can't add 2x plus 4x here because they're different bases. See, now they're the same basis. Now you can add them together. So what's 2 to 6x times 2 to 8x? You add up 6x plus 8x, so you get 2 to the 14x divided by 2 to the 2x equals to 2 to the 16th power. Okay? And now the next theorem, remember, you're dividing, same base, make sure the bases are the same, and they are, so you just subtract them. Subtract the bases. So you will get 2 to the 14x minus 2x equals 2 to the 16th power. Okay? So what's the next step? You subtract the x's. 14x minus 2x is 12x equals 2 to the 16. Okay? Now that the bases are the same on both sides, okay, and you can just, the exponents just have to be equal, right? So you do 12x equals to 16. Since this is the same, the exponents, you just have to set them equal here. And now you got 12x equal to 16, okay? You get it? It's like the base is the same, so you just set the exponents equal. So 12x equals 16, you just divide by 12 on both sides. And you will get x equals to 16 over 12. And then, of course, we're going to reduce that. You know, divide by 4 on top and bottom. And you will get x equals to 4/3. And that's how you solve the exponents when it's in an equation. Keep practicing and study. This is a very good example to study. The only thing I didn't have in here is probably either radicals or negative numbers. But but other than that, is everything's covered in this one example here. So review the example. Make sure you understand, why, you divide and why all the theorems are in there. And we'll go over a couple more examples for exponents in part 5. And thank you.